Oh, that was a quick one. Well, hello, everyone.
Hello, hello.
Hello, hello.
Hello.
So let's put our faces a bit big so we can see our guests and everyone else. Well, welcome to another Monday Demystifying Post Production. And I'm joined here by my good friends, Thomas Drenth from
Yes.
Amsterdam, from a company called Sensu, and my very good friend and colleague, Max. And Thomas does some interesting medical and scientific work and in his company. And today's subject, following up from the other 2 weeks about compositing and AOVs, but with a twist. Today we are going to see the work done in Fusion Studio. So we did have some requests from users that we always use After Effects and so forth. And yes, it's the most popular of all compositing programs. But Blackmagic Design with the DaVinci Resolve and Fusion actually allows for a nodal workflows and whatnot. Thomas knows these things better than I do. I pretend I do. I don't. And will show us how to do the equivalent things using nodal workflows in Fusion Studio. Now, before we get into the subject, I need to go through our housekeeping. So I'm going to bring up my scene, and very quickly, if you go to the Maxon's event page, you will find all the events that are happening currently, links, and you can filter by date, regions, and so forth. So anything that's exciting, you'll find it over here. And of course, these live videos, they are recorded, and the timestamps are added courtesy of Dr. Sassy, and they will be posted only on the Maxon training team. So the recordings appear on the Maxon training team, but live, you can watch them on the Maxon training team, on the Maxon YouTube channel, and on the Red Giant YouTube channel. Now, besides these, we also have the ZBrush YouTube channel that has amazing content from great artists and artisans of ZBrush. And if you want to become certified, either as a trainer or a pro user, go to the certifications page. And over here in this little drop down, this little twirly thing, you can click on the certification topics, which will give you a number of topics that we consider at Maxon the baseline knowledge you need to have in Cinema 4D to start your journey towards certification. And you click these and it gives you some links and some other details about them. Now, to show you our appreciation for your participation in these shows for the month of February, which is still just over halfway through, you can go and claim your free t-shirt at using the passcode, which is all caps Redshift AOV, one word. Max, correct me if I'm wrong, if I've mistyped it, but I think this is the password for this month, and you only pay for shipping and folding. All right. If you need it unfolded, I don't know if you have the option, but it's a free T-shirt other than that. And lastly, don't forget to go to the News University and watch hundreds of high-quality tutorials. And don't forget the oldsuniversity.com that has a ton, over 10,000 tutorials on all subjects. Most of them are using older interfaces, but the technology presented and the knowledge is always relevant. There's an abundance of knowledge out there. And yeah, I think this is all I have to show for my housekeeping. And now I'm going to pass the knowledge baton to Thomas. So welcome, Thomas, and thank you very much for being with us. What are you going to show us?
Thank you for having me. I'm going to show one of the shots of a project I did last year for Tidal Vision. It's about a little molecule that cleans out the water reservoirs and the green culture from pesticides. Yes. So one of the shots I'm going to show you quickly. I'm going to stream this right. Just little shots of the molecule cleaning up with bacteria, some plastics, and falling on the ground. And do go back up to a nice little bubble. So for working on this shot, I'm quickly going to show you in Cinema what we have. we have basically the same thing. Geometry here, falling on the ground, using X particles to create some giant sand molecules, and going back up. That's basically it. To show the AOV setup I used for this, before we're going to go into Fusion, I show you that I made this giant list of everything that I use with some extras. We have the cryptomats, of course, that we're going to talk about, Z-depth, the diffuse for all your colors, the diffuse lighting, diffuse global illumination, object position, but I don't really use it. I tried it out just in case. Reflection filters, the raw reflection, refractions, filters in raw, the subsurface scattering, which I use a lot for my work because it's all organic, so I quite used it extensively. The world precision is a pass I really love for AOV. I'm going to show you later on why. The volume lighting, well, since we're in water, it's kind of a necessity to have. Specular lighting here, ambient occlusion, which I made from a custom shader. Motion vectors to do, for this presentation, I added a UV pass for this to show that you can retexture in Fusion. Same thing goes for the normals, and a regular subsurface scattering, just to show the kind of difference between the raw and the regular one. I saved everything out to a OpenEXR, because then you have everything nice in one file. And use the 16-bit floats for everything. I think that pretty much covers it for a basic setup for in Cinema. And what I eventually used is this giant node-based compositing in Fusion. So we're gonna rebuild basically what you're gonna see here during this presentation. So bear with me. So the same stuff that I just showed you are basically presented here. We've got our basically our diffuse passes here. We've got our lighting raw, our GI, our subsurface scattering. Let me quickly put them in the right way. Our ambient occlusion, reflection filters and raws, refraction filters and raws, our speculars, and our fog. So for people who don't know Fusion, let me quickly show you. When you first start up Fusion, let's make a new file. This is how you usually find Fusion. You got two view parts. You got your node based. You got your inspector where you can control all your nodes. Basically, it's the modifiers in After Effects for this. And you got all these nice little buttons for all the different parts that you can use. So we've got some parts for text. We've got some color curves, hue curves, color corrections. We've got some blurs. You can make some masks. Some particles you can add here, and parts of the 3D system. If you want, you can also find all the tools here, which are nicely listed for all the effects. Some TV filters for some grain, some organization, what you want. You can have some scripts, custom scripts. If you find them, you can code them yourself. You can create extra windows if you want, which is, especially if you work with more screens, is very useful. You got your help, and of course you have a file for opening, saving, etc., etc. So let's get into it. Let's see. We've got this nice little image sequence I created. Let's drag it in. You only need to drag in one because it understands it's in sequence. And let's get the Cryptomatte in here as well. This is what I rendered out from Redshift.
Thomas, if you can, on the bottom of your screen, that little thing, can you please hide it?
Yeah.
Excellent. Thank you so much. Thank you.
Okay, so we've got our timeline here, and we dragged in 2 renders up here. Well, right now we can't see anything. What you can do, you got these nice 3 little buttons here. So you've got your screen here, but you also have your screen here. And right now it doesn't look like the correct way as it should be. If you look at our nice presentation, still here, it doesn't match anything like it. That's because right now we're still looking at the linear way of the render. So let's turn this one off, and let's put this on full screen here. You can put a viewer here. As you can see here, there are different kinds of extra buttons here, and we'll go through it. So this is for the extra button. Let's see, what's this? No. Something checker underlay if you want. Transparency. Then we go through this one. This is where you put in your color space if you're working for ACCG, which, going back to my cinema file, if you looked at my projects, color management, I worked in ACCG, and eventually my displays was sRGB. So we need to add a display profile to this. So selecting OCIO Colorspace, I can go to Edit and load in a config file for this, which thankfully I do. Let's copy this over. You have this nice config. You can load it in, and it loads in all the presets from OCIO. Let's put the source space all the way up to ACCG, and output space, let's see, utilities, output to sRGB. There, that's a lot better. Okay, so node-based is very different when it comes to using After Effects. After Effects has the nice layers on top, and basically now you get basically this little thing, which doesn't do right now much, and you can't basically save anything. So let's add a saver beforehand, because and then you understand where I'm going with. So let's go to Tools. We can go to let's see, where is it? I usually do it automatically already with shortcuts, so bear with me. This is terrible.
Just a quick question, Thomas.
Yeah.
When you are using tools in Fusion Studio, because this is like different versions than the one that you have in DaVinci Resolve, can you also search for the tools using the Shift space bar?
Yeah, you can. If you use Control Space, you get a nice searcher.
So it's Control Space.
Control Space, yeah. This is how I usually find everything. That's why you see me struggling finding something, because usually you go here, you find the saver.
Yeah.
So that's where you usually go. Let's make a saver here. It immediately asks you where do you want to save. So let's put it let's see, on my desktop, just in case. Presentation, save. Let's see. Presentation, shots. Can we get different kind of files, which everyone kind of knows already. So we don't have to really go into JPEGs. You can go back to an EXR if you want to. It can be useful sometimes. PNGs, for this time, I usually go for a TIFF for this. Okay, go to save. So now we have a nice saver. But the thing is, you're not connected. So you got this nice little block here, which can drag to this triangle. So now they're connected. Great. So I could start rendering with this nice little button here and say, start rendering. Thing is, however, it's still in a linear representation. If I put this on 1, you can also just drag it, by the way. You can see the top here where you are. And let's put a view out. You can still see, well, it's incorrect if I'm going to save it. What you can do, let's go to Add New Tool. Let's see, for this. Let's make my life easier. Let's just go and search it. You can basically Google for OCIO and go to color transform. Let's see, no, this is the wrong one, excuse me. You need the color space one. Yes, that's the one. So you basically have to convert it before you're gonna save it. Let's drag this in here. Let's drag it in here. And same thing, we first have to find our config. Google it, find it again, go all the way up, your CG and your outspace. Okay, just type it in to sRGB. There you go. So this is basically your simple node system. You got your input here, you got your output here, and you got your color transform at the end. So this is basically what you need for working in node space. And everything you do between your input and output is where you do all your adjustments, all your composites, your AOVs, everything basically. So let's put this a little bit here. Okay, let's go back to this one and let's put our view transform back on. So we got our nice little EXR file here. We can go to format because we made a multi-channel EXR for this. Go to channels and see everything I used is basically in here. You got your objections, your fractions, volumes, everything is in here. And if you want to work with some extra utility passes, you can add them here. So your ZDepth pass, you can add them here, your depth here, your object IDs, your material IDs, UVs. Let's add them as well. Let's see, UV. And UV green, normals, same thing. Thankfully, everything is sorted like it kind of makes sense. Your XYZ just go to RGB, and the same thing goes for your position, passes. It's all based, just for your RGB. Did I go past it? Yes. GB, there we go. But we've added now all these passes, and that's all fine and well, but you don't see anything. Except if you look here, just this nice little button to show all the different passes you can use. So you can look at your red RGB passes, you can look at your alpha passes here, but now you can also look at your ZDepth, which looks white right now. But also your UVs and your normals, and of course your position pass. So everything's basically present here. I see I made a mistake here. There we go. Yeah, that's better. So that's basically it. You got all your passes in here, and you can use them to do all kinds of different parts in your compositing. Also, if you look at down here, you can see basically all the data you actually have in your render. So if you look at here, you get your RGBs, you got your A, but you got your ZDepth in here, and you got in the corner left, you can also see your position pass here. So let's skip through here. Let's make it land. This is your intro. This is for your time sequence when it needs to start. But if you only need to render a specific part, you can use this part, which you can use drag, but you can also type it in with your hand by numbers. So let's quickly put this in 350, so we know that this is the end of our shot. And we've got our Cryptomatte going right here, which I'm gonna talk about later. But now we have the problem, how are we going to use basically the AOVs that we have here? Well, we can do it by hand. We can basically make a copy and format, set everything by hand. It's a giant mess. takes way too long. So you can basically have your ambient occlusion right here. But thankfully, there's a giant community for Fusion users, and they set up this nice little system called Reactor, and Max knows this. A Reactor basically has this whole bunch of collections of different scripts, and one of them is actually super helpful. And yeah, exactly. Well, that's the one for the Cryptomatte. If you want to use Cryptomatte, we'll get to that in a second. There's one of the scripts, it's called Split. It's by House of Secrets here in the Netherlands. And what it does is basically you select your beauty pass and basically says, well, we want to split your multi-channel EXR. Well, can not use this, go to run and close. And basically it splits out your AOV and all the different passes you have. So now we've got a refraction, we've got our subsurface, we've got our UVs. We can basically have everything we need for using this. There's also a Cryptomatte that comes within the beauty pass, but it's quite different than the one that's rendered separately. And I'll get to that in a minute. So we've got all our passes here. So now we can start rebuilding our beauty pass. And I don't know how many of you already watched the previous sessions, so I won't get into too much the details of rebuilding a beauty pass for this. But let's put this everything a little bit in order. UVs, you don't need those separately. Same thing goes for position pass, because we still have everything in here. And I'll discuss that in a bit on why this is so useful. We've got our depth pass, which it shows it now better. We've got the diffuse, and let's start with that one. So we've got our diffuse filter. And the thing is with the script, however, it's that it ignores the alpha channel for this. It doesn't use it because it only looks at the different names for your channel, and because you only need one alpha channel basically for your entire shot, it ignores it. But you can just add it back in. So let's get our diffuse lighting. And now comes the thing on how do you combine these different passes together. For creating your regular lighting, you have to multiply this. Well, there are two ways you can basically combine your different AOVs. We can create basically a merge, which does what the name says, or we can use a channel Boolean, and they can basically do the same thing, and but on a different level. So let's start with this. Well, same thing. We can add it in here. We can drag another part. Got this because they have different little triangles. One thing goes for the background, one thing goes for the foreground, and one is for effects, basically adding masks. So let's drag this in, and right now it doesn't do anything. So let's click on the merge. We got this nice little setup, and with all kinds of different tools. You got your center, which you can move around. As you can see, you see your background here. You can change the size, angles, etc. Flip it. Then we get apply modes, and everyone uses Photoshop or After Effects, knows most of those parts. But the most noticeable part is that additive isn't available in here, because if you want to actually use it, you have to remove basically the alpha gain for that. So then you basically this is how you make an additive for your AOVs. But we don't need that right now. We need a multiply. So let's select multiply, and it's multiplying both shots right here. Then we have, if we want, we can still blend it together, or we can select a nice little mask here, and it masks it. Same thing goes for the mask. If you select it, you get all your instructions here. You can move it around. You can make a soft edge. You can make the border width. And you can change the size of your mask.
Thomas, do you mind if I interrupt you for a few seconds?
Yeah.
I say this very often, but I always feel I need to repeat it, that when you multiply images together, although multiplication always makes us feel that we're making numbers big, in fact, because we are multiplying with numbers between 0 and 1, because imagine that's the spectrum of a gradient, right? Or from 0 to 1. Well, if you multiply any value with a number from 0 to 1, the maximum you're ever going to get is the same value. So 1 times 2 million is still 2 million. But if you multiply any number with a number less than 1, which will be a random position in your gradient, it darkens it. That's why we use multiplication to apply darkening effects like shadows, ambient occlusion, and so forth. This is one of the things I repeat very often, just to make sure that people understand that in this case, multiplication, it doesn't imply the increase of light. It implies the decrease of light, because we're multiplying the underlying color you have, whatever pixel that is, with a number from 0 to 1, which could be any shade of gray. And that reduces the value, thus making it darker. Thank you.
No, thank you. That's always good info. Also, it's terrible marketing from Multiply, by the way. Calling it multiplying and it darkens. All right, so let's see. Then we go to our global illumination. Let's put this on the side. Same thing again. We've got our GI here, and we have to multiply this with our diffuse. But before that, I quickly forgot, we also have our channel Boolean, which I said was kind of doing the same thing. So let's drag the same thing here again. Let's get our diffuse here, we get our raw lighting here. And right now, you got different kinds of operations you can do here. So same thing here, you can add, you have an add, subtract, or can make a multiply, you can make a negative. So there are different kind of options you can use for channel Booleans. There is one thing that you have to keep in mind, which I'm going to show you in a bit. So right now you can use multiplier for this, but it's also multiplying the alpha. So it goes from red to green to blue, but it's also multiplying the alpha channel for this, which often than not you don't want, because as you can see right now, the difference is like if you go to merge, the multiplication on the alpha channel, it doesn't do anything. Ignores it basically. But for the channel Boolean, it also uses the alpha channel for this, which sometimes you don't want. So if you don't want to use that, you basically say do nothing. Then it should do fine. Right now it doesn't. I do not understand, but no idea why. But the extra part about channel Booleans is that all the passes I just showed you in the beauty pass for the positions, you can basically add them back in here if you have them. You can enable them. You can bring back your Z buffers or your normal passes, your vector passes. You can add them back into a pass. Because right now, if we look at their channel Booleans, we only have our RGBs. But let's say we want to add them. We can basically say, go back to your normals. Put them back in, even though it doesn't do anything right now. You can put them back in and use them if you want them. So that's the big extra part I think about channel Booleans. You can add basically the extra utility passes if you want.
Thomas, can I ask you a question if you don't mind?
Yes.
Because I don't know fusion, right?
Yeah.
So I know more about nuclear fusion than fusion. So sorry about that. can't stop myself. So in Redshift, we have the material layer and the color layer, in which we input a number of materials or colors, and we use a masking or a blending option. Is there something similar that works in Fusion, or do all the mixing, if you want to mix 5 different images using masks and all that, do you have to do it sequentially? So that's a legitimate question by me.
That's a good question. I'd say I'm using Fusion 17. I know they're in 18. They've got a multi-merge where you can add basically different kinds of layers together in one merge node. But for regular, I'd say you have to do it sequentially.
Okay, thank you. Because that's, with Cinema 4D standard render and with Redshift's material layer and color layer, we can combine a stacked approach and a nodal approach. So, okay, that explains a lot. Thank you very much.
Yeah. No
may I add something about multi-merge? Yeah, I think what Thomas pointed out is correct. It's just within that one particular node, multi-merge, you can stack up as many tools as you want, and you can see it as a layer-based node within a series of nodes, so to say, using the multi-merge.
Thank you. Good to know. Thank you very much.
And by the way, 10 assists.
Oh, great. I need that.
Carry on, Thomas. I'm sorry.
I love that, it takes you 5 minutes before the padum actually shows up. Fantastic. Okay, so I'll quickly go through building up an AOV. I don't think I really have to go into the specifics on how to rebuild an AOV for this one, right? Because we covered that on the previous sessions. So let's make a regular raw for this again. And quickly going to show you a quick tip. If you drag one end to the other end, it creates another merge. So that's very useful as well. Same thing, we're going to multiply this, and then we can create one regular lighting pass from this. So now we come to the part for creating a additive. So for additive, we remove the alpha gain, and this is basically our lighting pass. So right now really dark. That's because I use a lot of different kind of materials for this shot. So it's not just your regular diffuse and lighting for this. Let's see, I used, this one has that. Let's add our alpha channels for this as well, just to make life a little bit easier. So now we have this one, and it's all combined. Awesome. So let's go to our subsurface scattering. And I rendered out 2 different versions just to show the difference, because just like the raw you have here, you have to multiply it first with your diffuse filter. So we'll do that. We get this nice, again, a merge. You can do multiply, and this is your regular subsurface scattering. But I also rendered it out separately. And as you can see, these are pretty much the same. And this is how it is in the raw version. It's really subtle, but there's a kind of difference. So I would say usually you can just use the regular subsurface scattering. You don't really need the raw. You can try it out, play with it, see what it does. So for this presentation, I quickly gonna set it aside and use your regular subsurface scattering. Let's drag this in here. Set this to 0. There we go. Put this on alpha. There we go. Let's add our refractions for this. Specular goes here. Volume is for later on. Reflection filters. and the rest of these. There we go. So let's get a refraction. Same thing, it's a raw version, and everything that's raw first needs to be multiplied with your filters. So this is our refraction, like only this sand pieces are right now using refraction, just for the sake of showing that we actually have some data in this pass. You can see this is the nice little mask for it, your filter. We'll multiply this, put this in here. Let's see, the raw, same thing, let's drag it here. Let's multiply this as well. So this is your regular reflection, your filters for it combined. And let's put these all together. Put alpha gain on 0 and go away. This is almost done. See here, I'm still missing a couple of alphas. Is there an easier way to do this? Yes, there is, and I'm going to show you it in a second. Let's first do it the hard way. And we still have our specular. Same thing. Let's just add an alpha for this. Put this together. We've got our specular, and the only thing left is our volume lighting, which is this nice little dark blue, because it's at the bottom of the ocean. Put these together. Use the alpha gain. As you can see, it adds a little bit of the blue on top of the geometry. And that's it. Now we've pretty much got our beauty pass. So we look at it. It's pretty much the same, except for this nice little white edge around it. And that's because our alpha channel is actually not post-multiplied. So basically it starts from the beginning already. If you multiply it, you can see here, there's this white edge going around it. It's very easy to fix. You can add a post-multiply here, and it already removes it. And the same thing goes then for everything else. And that can be such a haggle to do. So what we can do is basically get an alpha channel from a previous shot. So let's say we'll add a channel Boolean for this, and so because we want to have an alpha channel from a different shot here. So we go to channel Booleans, and if you hold Shift, you can put it in between a node. Fantastic. Say we want to have the beauty pass of our, right now it doesn't do anything, of this pass. We'll quickly put it here, add it, and right now this is the background, this is the foreground. Quickly, let's see, and switch it around if you drag it, because we want to have basically, where are you? This to the foreground. There we go. So, no, I did it wrong. Well, it doesn't matter, because we can basically say, well, we want the background from the red, the background from the green, and the background from the blue, but we want the alpha channel from the foreground. And so we can basically add a background or an alpha channel back into your node-based wherever you want. So we, instead of basically going to the format and adding an alpha channel, everything, you can basically say, well, add an alpha channel at the end, and it can fix everything. But like beforehand, just post multiply it, should fix it, but it doesn't. That's probably because right now I added alpha channels to everything. But that's fine for now. So we have our basically our basic AOV beauty pass back here. And what we can do is basically drag this back here. So now everything we want to do will be saved to our presentation export. And now we can basically adjust every layer we want. We got all these nice little nodes connected. So basically going from the beginning, all your loaders, all the way to the end to your saver. Let's delete these for now. I have an ambient occlusion, but I rarely use it. So, but the same thing goes for the ambient occlusion. We'll add that basically here after the subsurface scattering. Can drag it in here. We'll merge it in between and say multiply, and you can blend a little bit on how much you really want the ambient occlusion to be visible. So now we can start adjusting our scene and say, well, where do we want to adjust the colors or just the reflections? So we say, well, we've got this volume, but I don't like the color. What we can do is basically go to look for a color corrector. You can say add, and it adds a nice color corrector to this. Color corrector works on different levels for this. You got your regular colors. You can look at the levels for this. Got different ranges for what you want to adjust. Your shadows, your midtones, and your high tones. Got different options and your settings on how much you need to blend this and which colors you need to process. For your, let's go back to colors. So you got your master, which adjusts basically the whole picture. So let's add some gain. Or you can basically say, well, I only want to adjust the shadows. Say in the shadows, I want to make it a little bit more pinkish. We want, or a bit more greenish. And you have basically full control on which parts of the image you want to adjust. Now, you got your contrast, which doesn't always look nice in linear workflow. So I wouldn't really recommend that one. You could just use the gains and the gammas for this. I'm gonna adjust a little bit, add some saturation to make it a little bit more funky. Change the hue a bit, and got basically full control on everything. And the same thing goes for your subsurface scattering. The molecule right now I have here is a bit yellow. Let's say, well, I want to have a different color. Let's add a color corrector to this. Let's say, well, add a little bit of reddish to this. Because we can. Saturation. The end. You have this red with blue scene right now. Let's say we want to go to our specular lighting. Say, okay, that looks funky. We've got some nice speculars in here. But no, it doesn't pop enough. What we can do is add a glow on top of this. So same thing goes. You can just look at the glow, add the glow to this, it starts to glow. You got different kinds of glow also, because this is just a regular glow on top of everything. If you really want to blow it out. But there's also a thing that's called soft glow. And soft glow is basically looks at the threshold of your image. So let's lower this or move this a bit up. So now it just highlights all the glows just all the highlights. Can make glow a little bit. Let's put the gain a bit down to make it softer. And there's this nice color scale if you want to adjust it a little bit. No, make it a little bit more reddish. Well, let's make it more blue since we're underwater. And that way you can adjust different parts of your scene. Now let's go back to the Cryptomatte for this, because I want to change the colors of all these little pink plastics. And we've got those are baked in their diffuse for the texture. And we rendered out 2 different Cryptomattes, and there's a huge difference between these 2 Cryptomattes, and I'm going to show you the difference between them because they kind of look similar. The thing is, however, the Cryptomatte that's rendered separately actually has all the extra metadata you want to use, and with that I mean this. When you use Cryptomatte, it understands what kind of object it is, because there are 2 different ways you can use Cryptomatte. There's you can use basically a regular keyer, basically picking out the colors, which I'm going to show you. Let's see if we can actually find it. If you can find matte, yes, you can use basically a chroma keyer. You can put it in here. And you can basically say, well, let's use just the color and say, well, we want to back this one, can make this one, and you can basically mask it like this. But there's also a plugin for this. It's from the guys at Psyops. They have, I think they invented Cryptomatte, prove me wrong. And they created this nice little plugin for Cryptomatte. So let's go to Cryptomatte. You can get it from their GitHub, but you can also get it from the Reactors plugin. Let's see, let's drag it in. Right now, it doesn't understand the regular part. Let's drag in the separate Cryptomatte. This one it does understand. Because right now, we can pinpoint everything here and say, let's add this. And it says the name of the object. Because I'll show you, there's this nice little thing. It has basically all the metadata of your rendered scene. Now, which objects are there, your camera data, and all the extra stuff for that. Which the regular that comes in your Beauty Pass, it does not. That's why the Cryptomatte plugin doesn't understand your colors here. It's basically, well, it's a picture. It doesn't understand it. It needs the metadata to work. So the separate Cryptomatte layer is actually the one you want to use if you want to mask. So let's delete this and use the Cryptomatte for masking. We can basically start adding everything here. You can just add. There we go. And you can basically add all these different layers, objects to create a mask. But if you don't have to plug in and don't want to use it, you can still do the same thing with chroma keyer. You can still select all the colors. The thing is, however, with a regular keyer, it adds up all the colors. So eventually, like you see happening here, it adds basically the different colors together. So eventually, you need to create more masks and combine those together. Can be a hassle for that. So let's Cryptomatte.
So, Thomas, I think the chroma keyer is using the color value to create the matte, right?
Yeah.
And the Cryptomatte is using the metadata to create the matte. So I think it's a more precise, option to create the matte.
Yeah, exactly.
Cool.
Okay, so let's say we've got our diffuse and we want to change the colors around here. Let's add a same thing. Let's add a color corrector. Color corrector for this, and say we want to change the different colors. Say we want to go a little bit more bluish. But yeah, everything goes right now. Thing is, however, right now if I'm gonna plug it in, it goes to a match reference. It's not necessary right now. We have to look effect mask. There we go. Because we selected these different parts, it understands that it needs to adjust these different parts of our render. So if you go all the way to the back, we now have some nice blue particles which we can adjust. Awesome. Let's make it a little bit lighter so they can really pop. That's great. Let's say, well, I don't like these stones are on the ground. I don't like the lighting here in front. Well, that's where we have still this nice little beauty pass around here with all the extra utility passes that I mentioned in the beginning of this presentation. What we can do is add something that's called a volume mask. What a volume mask does, let's add it in here. What the name says, it creates basically a mask of your scene. You can basically pick point it here, and we can scale it up. So make it softer, and you got different kinds of options. You got a cube, you got a sphere, and you can basically place it in your 3D scene. The fun fact, because it uses the world position pass of this, if the camera moves, your mask still stays in place.
Can I jump in, Thomas, for a second? There was a question before that ties into what you're saying. That's why I'm jumping in. And the question, I'm putting it up, says the difference between normal and position map.
Yes.
Now, yeah. The basic understanding is that, first of all sorts of data, when we're doing compositing, is represented using colors. But essentially, a lot of this data is not really relating to colors. A diffuse map, a specular map, all those are colors. But we're talking about data channels, the depth map, the normal map, and the position pass, and all that. Those are numbers that indicate for each of the rendered pixels, the position pass will give you the XYZ position in world space away from the center of your scene in Cinema 4D.
Yes.
But because we're compositing, the data is expressed in colors. Whereas the normal map gives you for that pixel where the pixel is facing. Again, using RGB to store the XYZ values for that direction. So a normal pass is for every pixel. How is it facing? Where is it let's say for that particular pixel when it was interpolated using the render and all that, where was the direction of the normal? And that is just stored as an RGB value because a vector can be expressed as a color, although it may not be color data. The relationship between data and colors, my close analogy is the movie The Matrix, where the whole world was just those numbers that were falling down in the screen, those symbols. That is the data. But the whole system was translating that in a real life experience, which we could say are the colors. So data channels, including the depth map, is representing a specific parameter, whether it's position, whether it's direction, or whether it's distance from the camera sensor. But because we're working with compositing, it just appears as color, although what you see doesn't really make sense. You can use it to do all sorts of interesting effects. But if you use it as data, you will see those weird colors. And one more thing I'd like to say is that because the visible color spectrum is usually from 0 to 1, data like the position pass, after they exceed 1 meter or 1 centimeter, depending on what unit they're using, they're just going to blow out into white. But if you go with a color picker, you will see that those values are larger than 1. It's just that the monitor cannot see it. So that's the position data you're showing, Thomas, isn't it?
Yeah.
So we can see red. Well, red is on the right, which is the X. Green is on the up and down. That's why the top part is green. And Z is closer or further from the camera. The black things you see there is because there's a negative value which cannot be viewed as a color. But when the composition software, whether it's After Effects or Fusion or anything else you're using, actually uses that negative number so that it knows what's going on. That's all I have to say. Thank you.
Yes, I think that's really good. And I think, like you mentioned, it looks at also at the values of your 3D scene, like your values, your plus values in the X go actually, you can actually see it's white. Everything, your minimum values of your X actually go to dark, as you can see here. I think that ties in with what you're mentioning. So let's go back to creating a nice little mask for our stones. Can scale it up even further, or say make it downwards. So we have this nice little mask of our stones here. Come to color and say, well, we want the mask only for this. So we only have the mask. Let's see which part we need to use for this. We've got difference here. Eventually, I think, yeah, it's into refractions. So we'll add a mask, a color corrector in here. Let's go to Control Space again, add color corrector, add it in here, and let's plug this volume mask in there. Sometimes also your mask, what you create with images or whatever, doesn't work. So what you can basically do then is add a bitmap mask. Let's see if it's actually in here. Doesn't. So you can basically go to bitmap and you can say add. This allows you to basically drag any object you have, any render, and create a mask out of it. So let's drag this in here. And right now, it understands that it has an alpha value. That's great. But let's say we want our ambient occlusion. Let's drag this in here. It doesn't show anything right now because it's looking at the alpha channel. So let's say we want the luminance to create a mask. It picks now the luminance value, and we can use this now as a mask to adjust our scene. So let's put this back into, let's see, effect. And right now it only adjusts where we have our ambient occlusion layer. Let's plug our volume mask back in. And right now it goes like this. If I'm gonna lower this, we get this kind of shadow right now. Maybe not what I want. What I can do is go to invert. Say, well, I want to darken everything else. And you can basically have this entire scene played out. But thankfully, because it uses a world position, if I go to different parts of our scene here, where the object actually goes up, it still understands, let's put this like this, where you are in your world that you rendered out. And since someone actually asked what you can do with a normal, well, I don't like the lighting on what we actually have here. So let's change the lighting for this, which is where you can use the normal map for. There's this thing, let's see, it's called a shader. And you can basically relight anything in your scene using this. Let's put it in here.
I have a question for you, Thomas.
Yeah.
Out of curiosity. So, if you just render a scene with uniform lighting around it, no contrast or anything like that, could you essentially relight a big part of that using a normal pass and what you're doing now?
Most of it, and there are limits, which I'm going to show you. Let's drag our. I see, this is why. Kind of figured. Let's put this back in here. Because right now it needs a normal map for this. I didn't put a normal map in our regular AOVs. So I'm going to use the beauty pass for this. And Right now, it kind of looks weird because you got different kind of values you can use here. We can add basically more ambient light, basically diffuse, a little bit more specular, and we can rotate our light where we want to add more light. But as you might have noticed, there's no shadow basically casting because it's not actually relighting in 3D. So that allows you basically to add some lights or highlight parts where you want, to give it a little bit more effect, but it doesn't really cast shadows.
Technically, I'm thinking now, maybe if any people from Blackmagic Design are watching this, well, if you have position data, then you could create fake shadows because you'll have to trace from each position from the light. I'm thinking out loud now. No, it's interesting. It's very interesting what you're doing, but I understand the problem with shadows, right? If there's an object obscuring the light, it will cast shadow on everything, for example. So now I understand the limitation. Thank you.
Yeah. The thing is, however, there's this nice little thing which I will show you. I'm not going to rebuild it because it takes a little bit more time. You can use the position pass to recreate your scene back in 3D. This is my regular shot I used during the production. And same thing goes here. Let's go here. We have our beauty pass and we pick out our position from this. Pick it out. And we put it also back on an image plane in 3D. Perfect. So I'm quickly going to show you that there is an option for this, for those who want to know. There we go. Basically, this is a flat plane, what we're looking at.
That is impressive, I have to say. And funny enough, we have Pavel that just asked a question: which projects would you recommend using Fusion instead of After Effects? Which I'm going to let you answer that in a second. What I'm going to say, well, if you want to reconstruct your scene in 3D using your position pass and normal pass, maybe you need to use Fusion. But what is your answer to this question?
Yeah, it's basically, what do you want to get out of it, really? Let's see. Let's quickly go out. Because right now I use the displacement modifier and use the, let's see, world position, displaced this, or used the world position to displace the plane we have here. So we actually have a 3D representation of our scene. So if you want to relight, this is the way to do it.
And you can even add parallax if you want to change. Well, I guess you need to stay within the boundaries of, you can't go the other way around. The data doesn't exist. But this is absolutely amazing that you could actually get away with even some added parallax using this. I am impressed.
Yeah, well, the thing is, what you can do is, what I got here is I actually exported the camera using an Alembic from Cinema 4D. So this is the camera I exported from Cinema, and what I can do is basically, instead of a regular merge, you can 3D merge objects together. Say, let's get the camera in here. Let's get our 3D displacement. Put these two together, and let's say, well, I want to look at from the camera. So what you see right now is the representation of the 3D scene, but in Fusion. So this is basically your 3D scene. So if you want, let's say, I actually have one here. Say we want to add some 3D particles to this. Well, now you can. Go back to perspective. Let's see, where's my emitter?
So the canvas is an actual 3D world, right? It's not an additional functionality like we see in After Effects. Your actual canvas is a 3D world.
Yeah. I can basically, what I can do is, let's see. You can see right now here. Let's add another one. So I can actually see what I'm looking at, because I don't want to re-render everything. There we go. So this is what the camera sees, and this is now my 3D scene. So I can basically add some particles to this if we want. And let's say, well, that's all cool, and I want to do something cooler. I can basically say, let's add some smoke. Let's add some white smoke. And also put this on an image plane. Same thing. Put this on an image plane. Put this together in the merge 3D. And let's scale this up. Let's say by 50, a bit too much. And now I can basically add some extra dust in my 3D space. I can composite this back into my regular AOVs.
That's fascinating.
The thing is, however, like some, as you might notice, I can still see my regular image displacement, which is not what I really want. Let's put it in here. Let's merge it all together. Make it a little bit ghosty. Awesome. Let's quickly save this. So we can basically go to our image plane where everything's coming and say, well, we can make it a matte. Well, that's awesome. Let's make it a matte. Now we've got a nice little alpha channel of my 3D scene with some nice dust and some smoke. Okay, I can say, okay, cool. Let's render this out. Add a render 3D. Plug this back in. And hoping it won't crash. There we go. And now we've got nice little smoke with 3D objects. Cool. Let's go back to our regular scene. And let's plug this on top of it. We don't use self-illumination for this. Let's add another merge. Just to give you a quick idea on the power we actually have in Fusion. There we go. Looks a little bit wonky, but you can add it to the scene. Yeah, it looks weird because this is in 4K. There we go. Now it matches. So it gives you way more control on adding different parts in your composite. So it's not just regular, adding different layers on top of each other. You still have so much control throughout the entire scene. So if you want to basically add extra lights, you can add extra directional lines, which eventually you can add shadows to this as well. You can add some extra fog for this, some extra cubes, if you want. So you can be way more creative if you already rendered everything out, if you have a world position pass.
That's fantastic. And I guess the huge advantage that nodal systems have against layered systems, they both have the advantages, but the great thing is that you can pick from any stage of your stacking up of various images, and we use that in a different context. I mean, that is common amongst all nodal systems, including Redshift's material and so forth. So yeah, I mean, for anyone that likes to tinker, play around and add creative technical aspects to their renderings, I guess it doesn't have any limits. Fantastic. Great stuff, Thomas. Great stuff.
Thank you. Yeah, like you said, I can easily grab our specular and drag it all the way down here. Say, well, I want to put it right here. It doesn't really matter. The only thing you can't do is basically go backward really fast. So you can't go in a circle with all your nodes. So I can't say, well, I got this vignette or got my node here and I want to put it all the way back here. that will create basically a circular node.
Yeah,
And
circular dependency.
Yeah, circular dependencies, and it doesn't like that.
Yeah. Well, I'm pretty sure at some point they will add some sort of looping mechanism, because there are ways to limit this, so it's not an infinite regression into something. Do you have time to answer a couple of questions? One, Thomas, by Martin: does Cryptomatte not work with DWAB compression in EXR files? Does it work? I would assume it would, because it's just image data.
Yeah, I don't know. I haven't tested it yet, but Cryptomatte uses the metadata that it requires to find all the different layers. So I don't think it's really the compression that's really the issue. It just needs this extra data to find all the objects in your scene.
What's your favorite compression for EXR, if you can tell our users, because we get this question quite often?
Well, I converted from V-Ray to Redshift last year, so I use Zip for most of my renders.
So DWAB or DWAA?
I think right now it's just set on standard. I checked it out. Right now it's on default, but usually I just put it on Zip here. That's the one.
So some information for you. As far as I've heard from others, the DW, either A or B, seem to with half float, seem to give you the best compromise between file size and quality. So maybe you can try some of those. I personally have not tested it. I'm just telling you what other people have told me. So it's faster. The DWA series is faster than the Zip. There's something about the conversion. Max, what would your opinion be on that?
Yeah, I think Lionel pointed that out in the first sessions of this webinar. And he's also mentioning that DWAA was like worth the try. And I also post the link to the chat if everybody is curious to read more about the article that Lionel pointed out in the first session of the chat, webinars.
Fantastic.
I also know there is a way that Fusion reads EXR files, and I think there's different compressions make it work faster or slow it down. So that's something you have to keep in mind or look into it.
Yes. Well, we have another question though from Amanpreet that asks, it's quite difficult for me to understand complex node-based compositing. What do you suggest and how I should start learning node-based compositing, I would guess? I can composite basic AOVs in After Effects. Would you have an idea of a getting starter guide for users like Amanpreet or anyone else that wants to learn nodal systems?
Ooh, that's a good question. To be honest, I learned everything from Hugo's desk, which actually uses Nuke for his tutorials. But I used try to translate what he shows to Fusion. There are some basic Fusion tutorials out there. I know he's a Houdini guy, but it's Tim van Helsdingen. He has a whole list of tutorials on YouTube about using Houdini, but also about using Fusion and how to set up basic AOVs in Fusion. And he goes through basically what I said, showed here as well, and or more in a depth way, also using Redshift from Houdini. But I'd say that's a good way to start.
Yeah, I do have to add a comment that nodal systems have there's a dual component to anything new you use. One is the software specific one, right? So there are quite a lot of similarities between Nuke and Fusion. And if I'm wrong, Max, you can correct me. But So how do you get your preview? How do you split your screen? How do you, merge things and all that? The specific nodes, the details and all that. As far as the nodal concept, which applies to Cinema 4D's scene nodes and the Redshift nodes and Espresso nodes and all that kind of stuff, and any node system, there is a more generalized knowledge to understand the flow of data. As we say, what does a node do? What does it receive? How does it process it, and so forth? So my suggestion would be to first focus on the general technology. Just go out there and start watching general tutorials on what a node system consists of and how these nodes and little wires, what their relationship are to things like After Effects, where you have the typical stacked things on top of each other. The one thing I need to say as the very, very first thing is that when you look at Photoshop or After Effects and how the layer, the list you have in your composition works, what happens, it goes from bottom to top. So you add a solid at the bottom, a green solid. Then you add an image. Then you add on top the mask, and you tell the image to have the lumimat, so the mask from the layer on top. And the concept is that it executes the whole process of compositing, putting these together. And what that means is that each pixel looks at the pixel on top of it, reads what kind of blend layer or what kind of alpha channel that one on top has, and adds or subtracts the numbers and does the little mathematical formula. And that pixel at the end is going to be whatever color it's going to be. And the totality of those pixels are the images. So what is bottom to top in After Effects or Photoshop is left to right in nodal systems. So you start with an image on the left, then you add something to add an alpha channel. It takes that little node, you plug it in the alpha channel, and it does what it has to do. So that's what you need to remember. Bottom to top in most layered systems is left to right on nodal systems. There are exceptions. Houdini uses a top to bottom sort of layout. It goes from top to bottom, not from left to right, but most nodal systems go from left to right. That doesn't mean that you can always put on top of
you can go from top to bottom in your Fusion as well.
Yeah,
to make it a little bit more
recognizable. The inputs are on the left and the outputs on the right. That's my understanding of left to right. Whereas in Houdini, it's top to bottom. But the majority of nodal systems is from left. You put the inputs on the left, Espresso, Redshift, anything, the scene nodes and so forth. You put the input on the left, and the whatever result comes from the right. Whereas in After Effects, it goes from bottom to top. Max, you were saying something. Sorry.
Yeah, just want to add something. There's a flexibility in Fusions. It's really really flexible. You can go from left to right. You can go from top to bottom like Nuke, or you can even go from right to left. But just to just to get a good way to start from left to right if you're in Fusions. And yeah, again, like Peter Aquinde, I'm sorry if I pronounce your name wrong, shows in the chat, there are some great tutorial out there from YouTube. If, for instance, you want to watch some like really nice basic tutorials, the progressions is like really nice, check out Casey Ferris and YouTube. He's really great in explaining like this basic stuff, and even like having like a really fun project that you can follow with in Fusion. So that's one recommendations. And if you want to learn more, there is also resources in Blackmagic Design website. So if you go to Blackmagic Design, go select one of the softwares, in this case, DaVinci Resolve, and then you will see that on top, you'll have like a training tab. If you go to that training, you'll have like a video resources as well as books. And these books, you can buy the physical books in Amazon, or you can just download it for free in their website. And it is a really great, way to learn Fusions as well.
There's also Confusion on YouTube, which has different tutorials on Fusion, but also Fusion and Resolve. And he has this entire list of also using the 3D system to create an entire render. So definitely recommend that as well.
The pirate of confusions, right?
Yeah, the pirate.
Yeah.
That's fantastic information. Thank you very much. What else do you have for us, Thomas?
Oh, that's a good question. I got completely knocked out of my zone here.
Oh, hang on. While we are in the answering question mode, I know that it's probably already like overlooked, but Peter Aquinde also asked us one question, which is we haven't discussed. I think you were using like the brightness and contrast node before, Thomas, and also you're using color corrector node. And
Yeah.
Peter kind of asked, why does it seem that the gain settings in brightness and contrast work differently than in color corrector node? Do you have any idea?
I do not, but let's check it out. Let's quickly add a couple of, for those who really are into colors, you can actually add your waveform here as well. So you can actually see the values of your shot. And you can go to your vector scope to actually see all the values of your colors. Keep in mind that right now these are the linear colors. So if we go to the end, these are the actually colors that you're going to render out. And the same thing goes for your waveform here. So we're going to use this nice little waveform to check out your question. So we got our shot. We're going to add our brightness here. And we've got our color corrector. Let's put those here. Let's drag this in the brightness and this in our color. Let's do the brightness first. We can check the gain. Kind of looks like this. Put it on 2.33. And if we go to our color corrector, we do the same thing. And they do the exact same thing. So the gain is pretty much the same for color corrector and for brightness. I think this pretty much covers it, I think.
Yeah, I think that's it. Also, a great tips, Peter. If you want to check it, you can also try with a grayscale ramp, for example, and put your scope on that, and then you will see the way your control is moving. So by using grayscale ramp on your viewers, and then you can just do exactly what Thomas has show, and you'll be able to see that how do you call it, the change, because the grayscale ramp will be shown as a linear how do you call it, line that goes from 0 to 1.
I have a question, a newbie question for both of you experts on color. So we have the vector scope and we have the other thing we're seeing now.
Waveform.
The
waveform.
Yeah.
You have
you probably forgot the RGB parade as well.
Okay, no.
Okay, all right.
Here's my question. Does the waveform and the vector scope give you the amount of pixels that have either a luminance or an RGB value? For example, if I have one extremely bright pixel on a 4K image, will I see what am I going to see in that particular case? I'm trying to understand what we are seeing when we have the this thingy we're looking at now.
Yeah. Let me just go. Let me just give my how do you call it, best shot there, Noseman. This scopes, I'm not quite sure the one that we have in Fusions, but the one that you have in Resolve color page, you can target specific how do you call it, specifications. For example, if you can set the scopes into 8-bit or 10-bit, and you can even set it to HDR, which will be showing you a nit value that goes from 0 up to 10,000 nits. And
I said nits are things.
I'm sorry, the brightness, the measurement to measure brightness. Sorry. Okay. So you will say
no bugs on your head. I mean,
no.
Sounds like a little flea that jumps on. I don't have problems like that. Maybe here. So the brightness, okay. But sorry, 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 I'm interjecting. So Thomas is showing something very different, interesting. Sorry, very interesting. He's moving his brightness thing from left to right, and I can see that peak. If you move it up and down.
Sorry, did you just lost me? I mean, I think my connection just dropped.
No. I just interrupted you. Sorry, it's equivalent to. Go ahead.
Or yeah, we were talking about NIT before. It's the measurement of brightness, and what waveform shows you is that the image as it is. So you'll be reading the waveform from left to right, and it is representing your image from left to right. But what is flipped is that now the how do you call it, the darkest pixels on the left side of the image will be shown exactly at the bottom of the waveform, while the brightest pixels of that image on that, you know, that area where Thomas is showing, the brightest pixel will be shown right at the top, and the value in between will be somewhere in between, something like that.
So why is it important to know? And again, I'm a noob. Nits and fleas don't interpret properly. So why isn't up and down as important as left and right? That's what I don't understand. Why is it important to know the left and right of an image, and not? So I can put two opposing gradients on my screen, one going white to black and one going black to white, and that will show me a flat.
X. You will have an X in a waveform.
An X in the waveform. So over my head.
I can show you. I can show you like the basic way to read a waveform, but the basic way to read that is that Thomas, if you have like a grayscale image that you can like put into the viewer, you'll be able to see that waveform just read your image from left to right. The brightest pixel will be at the top, the lowest pixel at the bottom.
That makes sense.
Yeah.
That makes total sense. But
Let's
it's two-dimensional.
There we go.
Exactly. So that's what a waveform. It's a tool to help you read the state of your image. So if you have a over bright pixels, so you have a blown out pixel. So in this case, you will see that it will be the value of that pixel. It will be somewhere over the 100 territory, which is you don't want, which is you probably want to bring it down so that the outcome in your delivery will not be problematic. Otherwise, you will just see white pixels in the outcome.
So if you make the gradient vertical, you're going to see a flat line, right?
Let's see.
Yeah, you see a flat line. So I guess that it makes more sense to use it. I think you gave me the answer, and the answer is it's more an indicator if you have burnt pixels, so to speak.
Yeah, so you will be able. I mean, this is one of the tools that the QC used back then. So you'll be able to see like the pixels that is below 0 and the pixels that is over the legal limit.
Oh, it is moving up and down. Oh my! I need to look into that. That's fancy, right? Thank you so much for explaining that to an ignoramus like me. Thank you.
No worries, man. Always a pleasure. So back to you, Thomas.
Where were we? Are there any questions so far?
I think we're good with questions. Yes.
Okay, good. Let's see, where were we? Because I think we might need to add some depth of field to this shot. Because I was looking at the normal pass for this first. Let's see. Yeah, I wanted to add some blue on top before we completely went into the 3D system. Let's see. So I added some blue for this. Can add a little bit of curve if I want to. Can also do it like this. Make it a bit softer. I would like to say, but what you can also use basically this as well is we can make it white. We can turn off the diffuse and alpha, so we basically have a mask again. What we can use. So I'm going to do it like this. Let's zero this out. Let's see. Yeah, the controls are a little wobbly. But you can basically use this as a mask again as well. There's, however, another fancy thing you can use this for. I didn't tackle yet. What you can do is also add some reflections on this. So let's quickly go to my lights and add an HDR. So we got this machine shop HDR, which is all fancy. And let's say we got this thing for environment reflection map. So let's drag this in. And there you go. Now we can use basically this as a reflection back on your scene. Let's remove our specular. But that's all fine, but we want to make it spherical. So now you got some more top, bottom, you got different kinds of reflections. Now you can add back in your scene if you want. Now after you have rendered everything. Let's say it's glass. Let's make it refraction. Now it's kind of more refracting everything. Awesome. Can do some really cool stuff with that. But again, let's say, well, this is all fine and neat, but I only want to have it on my molecule. So let's go back to our weird place here. Go to our, where is our Cryptomatte here? Is it this one? Yeah, that's this one. Go to our Cryptomatte. And let's select our molecule. Put this in here. Let's select our molecule. That's molecule 1 and molecule 2. There we go. We have our nice shader here. That's cool. And let's merge it in here. Now it goes to everything. Let's add this on the effect. And there you go. Now you can add some extra reflections on your render. Look at the fog. Let's make this additive. Say, well, this is all neat. This is cool. Let's blend it down a bit. And this is some nice little effect. And now we'd say, well, it's too sharp. Let's add some depth of field to our shot. And I immediately will recommend, and I know it's been recommended on the different presentations as well, just to get a plugin for this. You can either get one from Frischluft, Lenskare. It's an OFX plugin you can use, or you can use the Robite Fast Bokeh Pro. Both are available for Fusion for using your depth of field. So let's check it out. Let's add Fast Bokeh for this. If you hold Shift again, you can add it. And right now it doesn't do anything. That's because we don't have the depth map yet. See, the depth map is fine, I'd say. Well, not really, but we'll get to that. Let's plug it in. Let's see, depth map. And let's start blurring. Great, now it blurs everything. Well, we've got a nice focus distance that it can pinpoint where it needs to focus. Nice, that looks neat. What Fast Bokeh actually does, you can render basically your separate pieces of your scene and chops. You can basically say, well, want to have basically the background, or your near zone, just show your front. You have your far, and basically where your focus is. Want to have those separately. It's also very useful to see where you want to have your focus. You can basically put it on focus zone and you can drag it around. So you actually know what your camera is looking at. So let's put it on here. And you can say, well, my focus width needs to be a bit larger, so everything is in focus. That's great. Let's put this in. And then we got some nice blurry environments. Awesome. Well, you can also do this exact same thing with Frischluft. So let's check it out. Let's see. Go to Tool, Frischluft, Depth of Field. Same thing. Put it in here. Let's see, where's the depth map? That's the depth. Same thing. Frischluft actually, however, has this, where is it? Pinpointer, where it needs to focus. So you can basically say, well, pinpoint the depth of my molecule. And let's put the radius up. Let's turn off our gamma. It's not required. And now we run into a problem. And the problem, as you can see here, which wasn't noticeable yet in this version, is that all the edges become blurry. And that happens a lot if you, start compile or adding depth of field in Fusion or any compositing. That because these edges are really are unsharp. They're basically they're not really well for using depth of field for this. So the option for this is to extend our edges of our Z depth. So let's add our regular alpha for this. And let's add our diffuse of depth in here. Let's add it here. Let's say, let's post multiply this. There we go. So we have an alpha channel. Awesome. Now we need to extend this. And there are scripts for this. One of them is actually on Reactor. And it's an X edge extend. It basically does what the name says it does. Let's drag both in. It extends the edges of your shot. Awesome. Now we've got some nice clean edges. Let's put this back in. And now we've got some really nice clean edges on our depth of field. We can blur it even further. Great. What also might happen is it's not noticeable here immediately, but sometimes everything in the background becomes blurrier as well, or it doesn't need to be. Right now it doesn't show that correctly, but you can basically say, well, it's not blurring my background correctly, as you can see here. It shows some different weird edges all around. It's not what I really need. So let's turn off our volume light and add it afterwards, just to have some more control over our depth of field. If you want to turn off any of your nodes here, you can basically select Ctrl-P and turn everything off. Right now, this was the background, so it says, well, you need to use this one. Well, I could basically plug it back in, or I could press Ctrl-T to switch it around. As you can see, switch it different colors, so you can switch around which is front and which is background. So let's switch it back in. So now we have a blurred plate with an alpha channel in here. Awesome. So let's add our volume light back in again. But we first need to blur this as well. But we're going to blur it without the edge extent. So what we can do is basically say, well, let's copy this, but I want to, where is it? Paste an instance of this. So, and why an instance? I'll show you why. Let's plug this back in. And now we have a blurred VOC pass as well. Because they are linked right now, anything I do in this one and change the radius, it will automatically adjust in our VOC pass as well. So that's very useful if you want to merge different shots, especially if you want to render out a foreground and a background and different passes. This is the way to do it. You can just instance your depth of field. And we can put these back together. And now we have a complete blurred foreground and fog both together. Awesome. So we basically have a whole AOV already with some extra reflections. We've got some extra fog passes that or volume passes that we adjusted. Awesome. We got some depth of field for this. Well, there isn't much motion blur for this, but I'll show you anyway. So let's go back to our beauty pass. Our beauty pass is right here. Let's add our velocity here. It's called motion vector. Let's see. Let's see, we got our, between everything, we've got our vectors here. And again, they look really blown out. And that's okay, we're gonna fix everything here. Yes, we do not have a motion vector, that's fine. Let's add let's see, vector motion blur for this. I'll add vector motion blur. And it needs basically the motion pass we've got right here. So let's plug it in. It says no. It understands where the vectors come from. We've got a vector Y, or we can just use the regular RGBs for vectors if you have them rendered separately and don't have it as a multipass. Both work fine, and I'll show you in a bit. So we can scale this up, and right now it doesn't look right. It kind of looks wonky. That's because the way it's been rendered is incorrect. That's odd. Also, quick thing, if you hold Alt and you click somewhere, you can add this nice little thing to organize everything. So if you see any examples of people organizing everything, you can basically add all these nice little digits and you can organize it the way you want. Just make sure it doesn't become a mess like this. Okay. So let's drag out our motion vectors from our beauty pass. We'll add a channel Boolean for this because it's an extra utility pass, and put it in here. Let's put it in here. Say, well, to red, we want our motion vectors. Let's see, our vector G. And let's see, vector Y. And you go to black. You also go to white because we don't really need them. Or you go to white. There we go. Right now, these are completely blown out. And one trick that I've learned along the way from other people is these vectors are basically incorrect. They are not, the colors are not centered basically. So if you want to do that, you need to add a brightness pass to this, and basically so, well, we want to lower the brightness by 0.5. What this does basically is it levels everything out. So say somewhere in the center, when the camera is not moving, everything should be black. Okay, if you look at here, it has more data than it should. So we'll lower it, and this is then the correct colors you have to use for a motion pass. So let's go back to our vector motion. And say this time, well, we want to use our red and our green for this. So these should then be the correct amount of correct direction of your motion blur. Right now it's a bit too much. You scale how much motion blur you want on your shot. So now we have our basic AOV already. We've got some cryptomats. We've got our depth of fields in different ways. We got our motion blur. Well, this is all coming along nicely. But let's say, well, this is great. let's add some more stuff. Since we're underwater, I want to have some more glow, especially if you look at here. Well, let's add some glow. Basically, let's see, can I find it here? Oh, this is cool. Let's add some rays. Let's put some rays in here. And what rays does, actually, no, does exactly what the name says. It basically looks at everything that's highlights and shoots out some rays. Same thing After Effects has as well. And you can drag it around here. Say that's fine. You can use different thresholds and exposures for this. Well, we can also say, well, I don't want to merge it over. I want to have it as a separate layer. Well, you can. Let's put it in here, let's say, and we'll add another merge. Let's plug this here, and let's plug this there. Awesome. Now we've got this data that's completely blown out. As you can see in the bottom, it goes to -2 and -3 in colors. We can easily add that, change that by making your shot additive again. And now the colors are correct again. So let's say, okay, that's fine. Got some nice here. Got some rays, we'll do a bit too much. And I want to mask it. Let's add a rectangle mask for this. Better we can just draw it. Okay, get a polygon mask, and we can say, well, I just want this piece to have a mask. Great. Let's plug this in here, and it's just masking that. Let's use a soft edge for this. Awesome. As you can see here on the right, it also said right click here for shape animation. It automatically always makes a key. So if I go to a different part of your scene, it automatically makes a key, which can be useful. So let's check it out. So let's see, let's go to a different part further. Calculate everything. Okay, that's cool. So let's go to our different masks. Let's select everything and move it on top. See, it becomes red and then automatically makes a key. Great. But I don't like the timing. I want to have it, keep on going a bit further. Well, now we can go to the corner top here, go to keyframes. Keyframes, you can basically see all the keyframes that are on your nodes. But this is way too dense, can't look at anything. So let's go to our 3 points here and say, well, show only selected tools. There we go. Now we can see our keyframes here. Let's see. Now I screwed it up. There we go. Go to polyline, we can select it and say, well, move it a bit further, we can move it a bit down. There we go. Well, this is great, but I think I don't like it that much yet. You can also view it. If you look at a mask, and you can play it, you can see it slowly moves. That's great. But I don't like the animation for this. So let's go to our spline. Same thing, go through 3 points, only selected tools, you select your polyline. Let's put this nice little button here and we can basically see our curves. Well, they're nice and smooth, but I'd say, well, that's fine, but let's add one here, that's one here. Let's have it move around a bit, see what it does. Simple as that, you can move it around. Well, this is great, but it's gonna be too much work if I have a shot that's 1,000 frames and I have to do this all over again. Well, that's actually not a worry, because I think you can use set a loop for this. There we go. We'll Control A. We can loop this. There we go. We'll eventually have to go down. And now you can make it loop. Going to be a little bit wonky. So you have basically all the controls you want for animation in here as well. That's useful. So let's go a bit back. We have this nice specular light here, and we have a glow here. Let's see. No, we're going to use it for subsurface scattering. We want to make this thing look really shiny. So we have our molecule here, and say, well, gee, I want to make it flicker a little bit. Well, we can. What we can do is basically add a brightness for this. We'll add a brightness. That's great. But I don't want to manually animate some jittering, flickering lights. Well, what you can do is do right-click and say, well, modify it. You can modify basically anything in your scene with different expressions. For this, we want to have a random. Let's add a random for this. And you go to modifiers. You got your tools, then we go to modifiers. We've got a minimum value of 0, which is not what I want. Or your maximum value. Well, let's put this on, say, let's put it on 3. Well, it says new value for every field or frame. Well, we don't want that. All right. A new value for every 5 frames. Well, that sounds reasonable. Let's check it out. Let's go all the way back and let's play this. So now we have this nice little strobe light of a molecule. That's cool. And the fun part about this is if you look at your splines, it actually shows your values here as well of your flickering light. Oh, that's great. Let's put it on eases so it becomes a little bit more smooth, or say, well, to have it a little bit more stretch out. So you actually have a more visual idea of what your values are. So let's go back. Goes up a bit more, goes down. Great. Well, that makes the scene a whole lot more organic. Awesome. And of course, everything will add up at the end anyway. So let's go. Let's put you back in. So now we have this flickering molecule. We have some different colors of plastics and microbes. Well, that's great. What's missing? What can we do? Well, let's say, well, we want to have a little bit more realistic lenses in there as well. Since we still have some time, apparently. Sometimes it takes some time. There we go. Well, you can basically add all kinds of different distortions for the. Let's go to warp. Let's go for lens distort. There we go. Let's plug in lens distort in here. So if you have basically a lens grid, you can use that as well to distort it, or if you want to go it by hand, that's all fine. Well, so let's do it like this. We can curve it around. Or say we want to have a different way. You basically have full control to add a little bit more curvature to the scene. Again, plug it in, and eventually that's the scene you'll have. I think we're approaching the 2-hour mark already, so I think we're going to wrap it up for this. So starting off again, you can easily add your AOVs from left to right, top to bottom, using different merge nodes and removing the alpha gain to make them additive, or you can make a multiply node for it to multiply. You can drag and drop basically any node where you want, and you can basically use any shot or AOV you want as a mask as well. And I think Fusion is crashing at this moment, so that's a perfect way to end.
It happens, especially with ad hoc presentations. I have to say that I'm very much impressed by what Fusion can do using standard AOVs and Redshift render and all that. And this ties into the last 2 weeks where Lionel showed the functionality, and it shows that when you have you're the right AOVs and you work with the plan, you know what to export, you can do so many more things. Oh, it recovered. That's fantastic.
Yeah, it recovered.
It recovered, so it was just a temporary freeze. But in any case, I think that everything we saw today was extremely interesting. And I want to thank you personally, Thomas, for sort of opening my eyes to this alternative workflow. And depending on the kind of work someone does or the way they use data and all that, what a huge array of functionality can be added to that. I want to remind everyone that next week, Lionel is going to touch upon mats, cryptomats, and puzzle mats, and alpha channels, and all that, because that's an essential component of compositing. And unless you have something else to show us, Thomas, although we are right before the second hour, we overrun by only 57.5 minutes. But I think that everything is useful, whatever we're showing.
Yeah.
Any closing words, Thomas?
No, I'd say don't be afraid. Don't be scared to try it out. I'd say, like, one of the questions, where do you need to start? I'd say just start. Let's just put it in and try it out. Just merge different AOVs together and see what it does, and try to make some mistakes and learn from them. I'd say that's the biggest thing I can give you. Just try it out and see what it does.
Yeah, I think the main thing being make mistakes, and the thing is they're non-destructive, and that's how we learn.
Don't be afraid to make mistakes. Exactly. I vouch for that.
Well, again, one more time, we appreciate highly your time to show our viewers the knowledge you have and the tools they can use. And Max, thank you very much for
Thank you very much, both of you guys. Thank you so much.
Thank you for having me.
Thank you for sharing your knowledge with us. And Nosman, thank you so much.
You're welcome. Thanks to all our users. Don't forget to grab your free t-shirt.
Exactly. And you guys in the audience, thank you so much for staying with us today for almost 2 hours. You guys are awesome. And don't forget to get your t-shirt. Okay?
Take care, everyone. Bye-bye.
Thank you. Bye-bye.
Bye-bye.